In last video, I have demonstrated a traditional way to calculate MACD indicators without assumed initial value. This method has certain advantages such as adaptability and bias elimination, but it may also come with drawbacks such as increased noise and potential delays in singular convergences. For details, I have a comparison list about the two approaches in a table and my website, which is a URL link I have attached in the video descriptions in below. Calculate MACD indicators with initialized first EMA value as the same as the first data point is another commonly used method because it offers a seamless integration into exponential moving average calculation, ensuring a gradually transition. Moreover, by starting the loop from the I equal 2 onwards and utilizing the preceding EMA value, it maintains the iterate nature of the calculation process. This strategy not only provides a smoother introduction to EMA, but also facilitates a consistent progression in capture trends, potentially reducing volatility in early signals and enhancing computation efficiency. In this video, I shall share a method to calculate MACD indicators with a summed initial value by running R script in Power Query. Okay, let's get started now. Continue with the previous Power BI desktop file. In Table View, select the original table, Multiply Stock Data by R. Right-click on it and choose the Edit Query. Then on left sidebar, right-click the table again to replicate the table as Multiply Stock Data MACD WI by R. As some R functions that work with the dates might expect them to be in a specific format. So let's convert the previous transformed date type back to the text type, which allow us to control the format and ensure compatibility with this R function. On top ribbon, select Transform, then on right top corner, choose Run R script. In pop-up R editor, we see the notice in top tells that the variable name dataset is holding the data content of the table, multiply stock data with MACD WI by R. Thus, we can work on the dataset in R environment for MACD calculations. Step 1. Load and format data. Load pre-existing dataset to the new name dataset variable. Convert back the date text type to the date type with format day, month, and year. Ensure the closing price is a numeric number. Step 2. Create EMA calculation function. Define a function named as calculate EMA that takes two arguments. X, the data for which EMA needs to be calculated. N, the period for the EMA calculation. The default is 9. Multiplayer calculation. This line calculates a multiplayer value based on the desired number of the period N. This multiplayer determines how much weight is given to recent data points in the EMA calculations. EMA initialization. This line creates an empty numerical vector named EMA with the same length as the input list X. This vector will store the EMA values. This line initializes the first element of the EMA vector with the first element of the input list X. This is because the EMA at the first period is simply the value itself. EMA calculation loop. This loop iterates through the remaining elements of the input list X, starting from the second element. This line calculates the EMA value for the current element I using the formula xi, the current value from the input list. EMA I minus 1, this is the EMA value from the previous period. Multiplier the calculated weight vector. This formula essentially takes the weighted average of the current value and the previous EMA, giving more weight to the recent data point based on the multiplier. Return EMA, this line returns the calculated EMA vector containing the EMA values for all elements in the input list. Step 3. Calculate MACD indicators by calling the previous created EMA function. Note the dplyr library for data manipulation. The new modified dataset frame to be with action groups the data by stock code to perform calculation for each stock separately. Sort data by date within each group for time sequences. Use mutate function to undead new columns. EMA 12, the 12th period EMA of the close pricing calculated using the calculated EMA function. EMA 26, 26th period EMA of the closing price. MACD, the difference between EMA 12 and EMA 26. Signal line, 9 period EMA of the MACD values. MACD histogram, the difference between MACD and the signal line. Ungroups the data after calculations. Finally, step return the modified dataset to Power Query. Now we have the R script ready to calculate MACD indicators. Run the R script in Power Query. We get the new dataset in table view with all expected MACD indicators. Check the calculated EMA 12 and EMA 26. Their initial values are the first closing pricing data point. Then the first MACD indicator comes from the difference between first EMA 12 and first EMA 26. The first signal line comes from the EMA of the first MACD data point. The first MACD histogram comes from the difference between the first MACD data point and the first signal line data point. This mixed approach with summed initial value has its advantages in terms of simplicity and computation efficiency. It's crucial to be aware of its limitations. Particularly, it may introduce a slight delayed onset to your EMA series and a delayed reaction to trend changes. Especially early in the time series, which could lead to missed trading opportunity or late exit. Additionally, in ranging markets, the accuracy of MACD signal may be compromised as the first data point might not be representative. That is all about in this video. Thanks for your watching. If you'd like to watch more videos from my channel, please press subscribe button. See you in next video.